I need to find the current through this 50 ohms resistance, and I need to find it using source transformation technique. So if I observe that these two can be converted into, since this is a current source and a resistance source, a resistance in parallel, it can be converted into a voltage source. So I will do that. I will do the conversion. This is also a voltage source, so I will use this symbol. This is another symbol for voltage source. The polarity will be plus minus because the current is upwards, 40 ohms. The resistance stays the same and the voltage is I into 40. So I into R is the voltage, which is 40 volts anyway. So 40 volts, and this one is, this voltage source is also 40. So this one is 40 here in the question. This is also 40. So this is 40. That's 40, and this one is 40. So 20 ohms, and this is the resistance, that's current I need to find out. So this is 40 again. So now these two can be added, these two voltage sources, so the circuit becomes something like that. So this is 80 volts now, 40 ohms, 40 ohms, and this is 20 here, and that is 50 here. It stays like that. So 40 plus 40 is 80. I will just erase it and add the resistances. So it becomes 80 ohms, and this is 20 ohms, and that is a 50 ohms. Now once more a source conversion can be done. This voltage source has a series resistance, so these two can be converted into a current source. So that I will do. So maybe I will use another color. Just so again the current source is, the current is upwards because the voltage source polarity was upwards. This resistance will come here, so the current will be 80 over 80 because current will be V over I, V over R, sorry. So 80 over 80, and that gives a 1. So it's 1 ampere. This is 80, stays 80. This one is 20, and this one is 50. So we need to find the current through 50 ohms, so we can find the equivalent resistance of this parallel combination. So that can be, I have to actually erase this on the top part. So yeah, so from here I am going there. It is becoming 80 into 80 parallel 20 is 80, and parallel 20, this is 80 times 20 over 80 plus 20, which should be 16. So 16 ohms here and 50 ohms there. 16 and 50, both ohms, and this is 1 ampere. So this current now I can find by current divider rule. So the current through 50 ohms is the total current, which is 1 over sum of the resistances multiplied by the resistance, the other resistance. So here 16, and this is the final current. If we just add it, it will be 16 over 66, and that's the current through I. So this is an example of a source transformation technique for circuit solution. So yeah, so this is actually 16 over 66 ampere, the result here. And in summary, the conversion is something like this. The transformation, a current source in parallel with a resistance can be converted to a voltage source in parallel with the same in series with the same resistance. So the voltage source value is coming by multiplying the current value and the resistance. So that's how it's 40, and the resistance in series is remaining the same. The other conversion is this voltage source 80 volt is in series with a 80 ohms resistance, so this can be converted to a current source and a parallel resistance, which is done here. And that conversion is again the voltage divided by the resistance is the current value, and the parallel resistance is the same as the series resistance, so it stays 80. And then finally the circuit simplifies this way, and finally we can use the current divider rule to solve it. So basically the conversion formula is nothing but Ohm's law. V is equal to I is equal to V over R. So that's how we find the current or the voltage value. We convert it the value of the current source or value of the voltage source, whatever. It actually is coming from just from the Ohm's law.